Okay, in chapter 10, we're going to go ahead and deal with probability and statistics. And what we're actually going to start with is statistics. So in statistics, we typically look at what we call data, and that's just information that comes from the real world. And we have two different types of data that we typically deal with. And what we're going to deal with today is what we call categorical data. And it's information that can be sorted into categories. Now, most categorical data is not numerical, but some can be numerical, like area codes, zip codes, or grade level. Now, these are numbers where it does not make sense to average them. So we don't average phone numbers, we don't average area codes, we don't average zip codes, and we don't really average grade level because it doesn't really make sense in the large scheme of things. Now, when we compare categorical data, we compare the data in three ways, and that is counts, proportions, and percents. So counts we use when we're comparing sets of data that are the same size. And so then we can compare the amount in each category, and that is we compare the number of subjects in each category. So counts is really just the number in each category. Now, proportions, when we're comparing sets of data that are not the same size, we compare the proportion of subjects that are in each category. Now, proportions are calculated by dividing the count, or the number of people in the category, by the total number of subjects in our situation. And proportions are always going to be a value between 0 and 1 inclusive, which means it can be 0 and it can be 1, and then any decimal or fraction in between. Proportions are also known as the decimal version of a percent. So a proportion, let's say if I had 50%, my proportion would be 0.50. If I had something like 8.2%, then my proportion would be 0.082. So here's our proportion, and then here's our percent. Now, that's our last thing, is percent. So instead of using proportions, some people prefer to turn the proportion into a percent. Mathematicians aren't really big on percents because you can't do mathematical calculations with percents. You can only do mathematical calculations with proportions. So typically, we write everything as a proportion, but we think in our head, oh, 0.5 is really just 50%. And so we mentally think about it as a percent, but we always usually write it as a proportion. To go from a proportion to a percent, you can multiply your proportion by 100, or you can also just move your decimal 2 places to the right. So for proportions, you move 2 places to the right to get a percent. To go from percent to proportions, you do 2 places to the left. And so it's just kind of that backwards motion relationship that there are between each other. Okay, numerical displays. So now, once we have all our data, we can do what we call a numerical display of data. And so these are really just creating tables so we can see how everything looks. Now, we have 2 different types of tables. The first one is a frequency table. And frequency tables allow us to state our category and then how many are in each category. And some people will actually do tallies on them and say, okay, I have 1 for here and 1 for here, and then 2 more, and then 1, and then 1, 2, 3, and then 1, 2, and go on, and then write the number at the end. Okay, so here I had 10, and here I had 4. And they can do a frequency table like that. But frequency tables are really only looking at the counts. Now, a relative frequency table now takes those counts and then turns them into a proportion, or turns them into a percentage, or sometimes both. And we'll typically be doing both. So we'll start off with our proportion and then turn it into a percentage. Now, once we have a table to help organize our data, now we move into what we call a graphical display. And so since most people are visual learners, I think about 70% of the population actually learns best by visually seeing pictures and stuff. So we can represent our data as a graphical display, which is really just a graph. And the most common graph for our categorical data is a bar graph. Now, a bar graph will have the categories on the x-axis and a space between the bars. So bar graphs has space between the bars. And then we will have either the count, the proportion, or the percentage listed on the y-axis. Now keep in mind, if you're planning to compare information, which that's usually why we look at data, is to compare between groups, we will be using our percentages or proportions to compare, because typically our groups won't have the same amount of people in them. And so to compare correctly, we need to compare percentages or proportions. So our first sample problem, we have a random sample of 10 ninth graders, and they resulted in the following gender for each person in the sample. So when we look at our variable of gender, we have two different categories. We have female and we have male. So when we create our frequency table, we can look how many are in each. So from here, I'm going to count how many females I have. Well, 1, 2, 3, 4, 5, 6. 6 females. And then I'm going to count how many males. So 1, 2, 3, 4 males. Which makes sense because we had a total of 10 10th graders. So that's our frequency table. Pretty easy. Now we're going to go to the relative frequency table. So again, I'm going to have my category female, male, and now we're going to create that proportion. So for a proportion, I take my count, so I had 6 females out of 10 total people, and I actually divide that. So on the calculator, I would type in 6 divided by 10, and that would give me 0.60. And now that I have that, I can now turn it into a percentage. So for that, I can times this by 100, or I can move my decimal 2 places to the right, which means this is really just 60%. And then I do the same thing for males. So 4 divided by 10, which is 0.40, which is 40%. So 60% of our sample were females, 40% of our sample were males. Now we go ahead and graphically represent that. So we go ahead and put our category on the bottom. And so we're going to have a female spot, and we're going to have a male spot. And typically, if you do like F and M, you have to say F equals female. A little key for us, M equals male. And then what we're going to do is for our bar graph, because we're going to end up comparing to another group, we're not going to put counts over here. We're going to put our proportion or percentage. And it's really up to you which one you want to do. And I'm going to go ahead and do percentage. And so now I can go ahead and I can be really creative and do colors. So I can say, hey, my females are going to be pink. And so I'm going to go to 60%. Well, I haven't labeled it. So now let's go ahead and say 10, 20, 30, 40, 50, oh, phew, 60%. So now I can go ahead and go up to 60%. So I have 60% of the females. And then I can go to males, which I can code as blue, and males were 40%. And remember, with bar graphs, they do not touch. There's spaces between them. And there's my bar graph. So this was our information for our 9th graders. So on our next problem, we're going to look at a sample of 10th graders. And this time we took 25 10th graders. So now we're going to go ahead and we're going to look at our categories again: females, males, and we're going to go ahead and count how many we have. So females, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 females. And then I can go through and count males. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh! And that's when I realized, well, hey, that doesn't add up to 25, so I did something wrong, which is why I count both to see if I forgot something, and I did. What did I forget? I forgot that there was a female up here. So really I had 13 females. So just a way to kind of keep track of everything. So now that I have my total counts, I can move on to females. and our proportion. So for our females, we had 13 out of 25, and I could divide that on my calculator to get the proportion. So 13 divided by 25 on our calculator gives us 0.52, which as a percentage would be 52%. And then we can go to males, and this would be 12 out of 25. So then we do 12 divided by 25, which would be a 0.48, which is 48%. And that makes sense because together our percentages add up to 100%, which is 100% of the people in our sample. So now we're going to go ahead and go to our graph. So we're going to go ahead and I'm going to go ahead and write female. Really hard to write sideways like this. And then I'm going to write male. And then I'm going to go ahead and do our percents. And then I'm going to go ahead and go 10, 20, 30, 40, 50, and 60. And so now we can go ahead, and for females we had 52%, so I'm going to go to 50 and go just a little bit above. And then I'm going to go to males, and it's 48, so I'm going to go just a little bit below. And then now we have our information. So the last part is what happens if I ask you to compare what's happening with 9th graders and 10th graders? So comparing the data. To compare the distribution of a gender between grade levels. This is asking us to look at the percentage or proportion of each gender and discuss how they may be different or similar for each sample. So sample A is 9th graders and sample B is 10th graders. So when we look back at our 9th graders, we had 60% females, and here we had 52% females. So 60% for 9th graders and 52% for 10th graders. And then for our males, we had 40% males for 9th graders and then 48% males for 10th graders. And so now when I start talking about comparing, well, both groups had a higher percentage of females. And so that's something I would say. And then I would go ahead and look more specifically at those numbers. For example, freshmen had a higher percentage of females. So 9th graders had a higher percentage of females. And how do I know that? Well, 9th graders had 60% versus the 10th graders had 52%. So there's a comparison there. Both groups had more females than males, and 9th graders had a higher percentage of females, and 10th graders had a higher percentage of males. And that was 48 versus 40. So 10th graders had 48% versus the 40% for sophomores. And so this is really just analyzing what is happening with these numbers to make sure that, yeah, you can calculate the numbers, but do you really understand what is happening? What do those numbers mean? So that way when we compare groups, we can really say both groups had more females, yet ninth graders had a higher percentage of females, where 10th graders had a higher percentage of males when we compare within the gender. And that's what you're going to be working on in class.